Okay, for 5, 6, and 7, notice how the directions say the measure of angle 102, or measure of angle 6 is 102. That means for all three of these, since that information is for all three of these, we can pretty much, each one of the problems isn't like a totally separate problem. They're kind of pieces of the same thing. Whereas down here in the descriptions, we're only told that these two are parallel. That's the only information we were given. So that means when we look at like question 9, that description is going to be totally different than the new description as part for 10. Okay? They're going to be a little bit separate. So it was 10, right? Yeah. 10 and 11. So let's do 10 and 11 together.
9. No, just kidding. I got 9.
Okay. 10 and 11. So measure of angle 13 being 2x minus 3. Measure of angle 15 being 71. Okay? Again, if you're having troubles with this, highlight the lines that are parallel or the lines that you think are parallel based off the information given. And then try to highlight the transversal that's part of it. One way to do this to get you to allow you to see it a little bit better, especially if the picture is a little bit complex, is if you take the whole image, and you move it. But if you take the image and redraw it off to the side, sometimes it'll be a little bit easier for you to identify that those are then corresponding angles. Okay, I think it's a little easier to see if you pull it off to the side and redraw it, okay, just with the information from those angles. Since those are corresponding angles, they're equal. Okay, their measures are equal. So if we can then set up an equation saying that their measures are equal and then solve that equation. So it's B. The same type of thing is true for 11. Okay, I'm going to delete this so I have some space to work. And then again, I'm going to highlight that L and M are parallel. Okay, measure of angle 12, 3x minus 4. Measure of angle 10, 2x plus 21. Okay, and the transversal that makes up those two is that. So I would turn around and try to bring this, recopy that off to the side, and notice then, and mark those two angles. These two angles right there, those are again corresponding. So they're again equal in measure. And then we can solve that and find out whatever the answer happens to be. X equals 25, so it's A. 13 and 14. Just says look at the picture as labeled, and then it says find X so that A and B are parallel. The converse of the theorems that we've been dealing with feel just like we're doing it the same way. We need to find X. That angle is marked with an X, and that angle is marked with an X. So just focus your attention on just those two angles, and if you do that, it actually looks like this, where the top one is 2x plus 10, and the bottom one is 3x plus 20. Okay? And if maybe writing it off to the side can get you to visualize that those are consecutive interior angles a little bit better if you draw just that information off to the side. Pull the rest of it, just pull it out of the picture if you could. Since they're consecutive interior angles, that means that they're supplementary. Okay, which means they add up to 180. Okay, and then you solve it. 5x plus 30 equals 180. 5x equals 150. X is then 30. Okay, so it's A. So that's that part. The second question is actually kind of difficult because first you have to get number 13 correct in order to do 14. Okay, but you have to. There's like an extra step, and that step we hadn't done before, but which is fine. It's just kind of an extension of what we were previously talked about. So now we're talking about finding the value, using the value of X you found in 13, find the value of Y. So if I delete that, because that's no longer going to be our transversal. Plus, we're not even talking about the same parallel lines. Now we're talking about AD and BC. And we're talking about Y specifically, so Y makes up that angle. We also can compare that. We can compare that to that angle marked with 2x plus 10. Those, if you look at it kind of sideways, you can see that they're consecutive interior. Because they're consecutive interior again, consecutive interior, we said that's what's up. They're supplementary, so they add up to 180. So even if we didn't know x, we could set this up, right? But we know x, so we should put the value in there for x. And then we go ahead and crank it out from there. 3y equals 120, so y is 40. B. Okay? Go. Which figure shows a line whose slope is 2 and that passes through 1, 2? So I would personally find out if it passes through the point 1, comma 2. That's what I would do first. So this one passes through. Okay, so that checks that standard. That checks, okay, all those points pass the same point. So really it's just a question of the slope at this point. So we're going to look at the slope. From here, try to find the slope on the next one. That's down 1, right 2. Down 1 is -1, right 2 is 2, so it's -1/2. So negative slope, it's going down from left to right. It's got to be a negative slope. From here, up 2, right 1, so 2 over 1. Well, we just found it. Make sense? Because up 2, right 1, which is 2 over 1. The slope is 2 over 1, and the point is 1, comma 2. Okay? Okay, number 17. Given the points, blah, are AB, line AB, and line CD, what are they? Are they parallel, perpendicular, skew, or none of these? Well, in order to determine whether it's any of those, we have to match their slopes up. Okay? Because we know that parallel lines have the same slope, and we know that perpendicular lines have slopes that are opposite reciprocals. So we need to first find the slopes of those lines, and then we need to turn around and compare those two slopes. So if you graphed it, just to get it to make, just to give you a visual for it to make sense. Okay, AB is right there, okay, and then CD, and now here's the deal with this. It's impossible to tell if those are parallel just by looking at the picture. You actually have to do some sort of calculation, okay? And if this, well, we don't know yet. So we can't just look at this to determine whether they're parallel. You would need to know their slope in order to verify that they're actually parallel. That's the only way that you can justify your answer on this. You'd have to graph it, if you graph it for a visual to get you to understand how to do it, but you actually have to calculate the slope in and of itself. So AB, so we're going to find the slope of AB, be 4 minus 0, 0 minus -6, which is then 4 over 6, which is 2/3. Okay, then you find the slope of CD, which would be -2, 0, 0, 3. So it's -2 over -3, which is then 2/3. They're the same slope, so they're parallel. That's the justification for whether they're parallel. Now, in a multiple choice, you could have graphed it and made a good guess, but on a free response, this is what's needed to get credit. Okay, parallel to the graph of y equals 5x plus 2, okay, and passes through this point. Let me give you just a visual of what this is. This blue one is going to be there, up 5, 2, 3, 4, 5, right 1, there. That line, third time's the charm. That line looks like this. Come on. That line looks like this. But the line we actually want is just parallel to that and through this point. Okay? The new line that we're actually looking for is that one in red. We don't care anything about the line in blue except for the fact that we know that the slope has to be parallel in order for our line to be perpendicular, or the slopes have to be equal for those two lines to be parallel. Okay? So the only information we really care about from the blue line is its slope. So that can help us determine the slope of the parallel line, which is the same slope. Does that make sense? So then we just look at this equation for its slope. We're using it. We're using it saying that that slope is 5, and it's a slope parallel to it is also 5. So we're using it just to find its slope, and we take these two things, and we can write the equation of the line through that. Okay, distribute. We get y equals 5x minus 10 if you do it that way. Again, another way that I do it, another way that I do it would be putting it in here. You put your y is 5, and you put your slope being 5 and your x being 3. Put it in there and then solve. And you get b is negative 10. So then you take your slope and b and you put it into y equals back into y equals mx plus b to get y equals 5x minus 10. Again, same answer. Okay? Did I clarify things a little bit for that?
Not really, but
Okay. If you need some more help on it, obviously you can watch the video too. Okay. Well, let's look at 20. That's taking too long. So, okay, slope negative 2 and passes through that point. Well, put it into point slope form. Y minus y1 equals m times x minus x1. Okay, if you use that formula, you have to memorize it. Tomorrow, you're not going to be given that, or on Monday. Distribute and then simplify. Minus 1. Okay, get that. Or you could use y equals mx plus b, where your slope was negative 2. So we put m being negative 2. We put x being 3 from the point, and then you can solve it for b. And then, so b is 5, our slope is negative 2. We can put it back into y equals mx plus b. Just drop it in there, negative 2x, and then plus 5 for b. Okay? All right. Any questions on the other ones on this page? Okay. Next page. Yeah. 5. What's going on? 5. Okay. For the figures, identify each pair of angles. So 5 is 1 and 8. I would draw the lines that make up those lines, those angles. Those are alternate exterior then. That makes sense. Off to the side, you can draw it like this. If you rotate it to the right, it's like that. Okay. Any others?
yes.
Okay. Find the value of x that make. Oh, we are saying that A, C, and B, D are parallel. So find the value of x. If you identify where x is, right there in that corner, try to draw in a transversal that matches with it, okay? And try to pair it with a measure that's currently given. If you notice the measure, we have a given measure of 85, okay? Those, then you can draw it off to the side if that helps. 85 there, x there. Those are alternate interior angles. Alternate interior angles are equal, are congruent. So those are the same measure. Okay? Again, you could turn around and you could, for 10, then since this is the same, kind of the same setup, you know, because x was already in the problem, we can pretty much just drop it in there. A and C we said were parallel based on the directions. We're trying to find the y. So you could use that transversal to help you out to identify it. If you know where y is there, we have 65 marked there. You notice that those two angles are then corresponding angles to each other. Corresponding angles. Since they're corresponding, they're equivalent. So it's 65. 3, go. Here we go. Find the measure of x so that those are parallel. So there's our parallel lines. These two are corresponding angles. Since those two are corresponding angles, they're equal. So we set them equal to each other and then solve for x. That make sense? 60. Okay. And then on 16, those are alternate exterior angles. Alternate exterior angles are again congruent. So we just say that they're congruent. Divide by 2, 37. Cool. Okay, 22. To find the slope in the y-intercept, you actually have to solve it for y to be able to just read it from the equation, which means you're putting it in the slope-intercept form, where then your slope is -2, and so m is -2, and b then is 9. Or, as Estabrook likes to have it, 0, 9. Okay. As a y-intercept, no.
Well, that's what you had in the answer sheet.
Subtract, add 3x to both sides. There. And then, of course, it says graph the situation, so we would turn around and graph. So the slope on this would be 5/2, and the y-intercept, or b, would be 0.5. So graphing 23, of the graph, sorry, I cut it. Thanks. Okay, let's look at then 24. 24. We want the slope of the line, or the equation of the line that satisfies this given condition. First, we want it's perpendicular to that line. So first, I'm gonna graph this line just so we get a visual. And I'm doing this to, 1, get a visual, and 2, hint on something on the test. So I'm gonna graph that line. So it's at -6. Down 1, right 3. Okay, and we want the line perpendicular to that line. So if I were to just draw a perpendicular line like that, okay, that would work. But to prove that that's perpendicular, to show that that's actually perpendicular, you would need to demonstrate that you know how to calculate the slope of that line. Okay, you would just graph a line and make sure you know the slope is opposite reciprocal. I just graphed some random point, some random line. In this case, we want the line specifically through -4, -5. Okay, we want the graph that's perpendicular and through that point. So, by the way, I can't tell that that line is perpendicular because I did not use a slope to graph it, so we don't know for sure that that's perpendicular. Okay, to know for sure, we would have to find the slope, and that's actually what we have to do in order to write the equation of the green line. We need to know the slope. So we actually find the slope because we know that perpendicular slopes are opposite reciprocals of a line that is perpendicular to. So our line is perpendicular to that line. That line's slope is -1/3. Our line's slope, being a perpendicular slope, is the opposite reciprocal, or just 3. Flip it, change the sign, so it'd just be 3. Now we're going to take this, and we're going to put them together and write the equation. Okay? The slope that we found and the point that we were given. And we drop them in, and we solve it. Plus 7. Okay? Does that make sense? A little bit. Okay, let's go ahead and do one more. Okay, parallel to the x-axis. Well, lines that are parallel to the x-axis are all horizontal. They have a slope. Horizontal lines have a slope of 0. So our slope and our point. You do y plus 3 equals 0, y equals -3. Or, if you know that horizontal lines have a y equals equation, and they go through that point, that has to be y equals whatever the y coordinate is. Either one works.